What if you woke up tomorrow and Earth was no longer your home, not by choice, but by necessity? Imagine a future where the air you breathe, the water you drink, and the ground beneath your feet can no longer sustain life as we know it. Could the next chapter of human existence depend on leaving this planet behind? As wild as it sounds, this is not the plot of a sci-fi movie. This is the conversation scientists, engineers, and futurists are having right now. What if our very survival hinged on colonizing worlds light years away, turning barren rocks into new Earths? It raises the question, are we prepared to become an interplanetary species, or are we already late to the game? Now let's talk about the real game changers, the technologies that are turning what once seemed like science fiction into a practical reality. Space travel is no longer just about sending a rocket up and hoping it comes back. We're talking about propulsion systems that could, in theory, take us to Mars in weeks instead of months. Take nuclear fusion, for example. We've all heard about how it's the holy grail of energy on Earth, but in space, it could power spacecraft to speeds we've never imagined. If we can crack the code on nuclear fusion propulsion, we're looking at cutting travel time to distant planets dramatically. And then there are ion drives, which are already being used in some spacecraft. They're not as fast initially, but over time they build up speed, propelling us much farther than traditional chemical rockets ever could. And solar sails, how about that? These are like futuristic sailboats, but instead of wind, they use sunlight to propel spacecraft across the cosmos. The best part? They don't need fuel. As long as there's sunlight, you're moving. So think of a fleet of spacecraft gliding through the solar system powered by nothing but the sun's rays. Sounds like something out of, right? Once we get to these distant worlds, how do we stay there? That's where terraforming and life support systems come in. Imagine landing on Mars and transforming its hostile environment into something that can support human life, creating entire ecosystems from scratch. We're talking about engineering biodomes, complete with Earth-like atmospheres, water cycles, and even vegetation. It's not just about surviving, it's about thriving long-term, on planets where nothing grows and no one's ever taken a breath of fresh air. Scientists are already experimenting with controlled ecosystems on Earth, like the Biosphere 2 project, which is a kind of dress rehearsal for building these habitats on other planets. And here's where 3D printing and autonomous construction take over. Instead of sending heavy equipment from Earth, imagine landing on the Moon or Mars and having robots start printing your habitat using local materials, essentially building cities from the dirt and rocks around you. AI-driven robots could be working around the clock, constructing habitats while we're still on the way. They can build everything from homes to entire research stations using materials like Martian regolith. So by the time humans arrive, there's already a place waiting for us. These technologies aren't just dreams, they're in development right now, pushing the boundaries of what's possible and making space colonization less of a distant fantasy and more of an approaching reality. Now, when it comes to colonizing space, the Moon is our logical first stop. It's right in our cosmic backyard, about 240,000 miles away. That might sound far, but compared to Mars, which is millions of miles away, the Moon is like a quick trip down the street. And it's more than just a stepping stone. The Moon could actually be our launch pad for deeper space exploration. Why? Well, for one, it has a lower gravitational pull than Earth, which means launching spacecraft from the Moon requires far less energy and fuel. Imagine setting up a refueling station there, a place where rockets can stop, refuel, and continue their journey to Mars, or even farther. But the Moon isn't just a pit stop, it's packed with resources that could be game changers for space colonization. For example, helium-3, a rare isotope that could be used for nuclear fusion, providing an incredibly powerful and clean energy source. There's also water ice, mainly located at the lunar poles. Water is essential not only for drinking but also for producing oxygen and hydrogen, which could be used for fuel. And then there are the minerals, stuff like iron, aluminum, and silicon that we could use to build structures right there on the Moon. So, what would living on the Moon actually look like? There are a lot of ideas floating around, but lunar colonies could take the form of both surface and underground habitats. Surface bases would likely be covered in thick layers of lunar soil to protect against radiation and extreme temperatures. But there's a lot of interest in underground habitats too. Lava tubes, giant hollow tunnels formed by ancient volcanic activity, could be the perfect spot to set up a base. These natural structures would provide shelter from the harsh environment, and we just need to outfit them with life support systems. And here's where it gets really interesting. Building a sustainable presence on the moon is going to take some serious teamwork. This isn't just NASA's mission anymore. The European Space Agency, ESA, is working on its own moon plans, and private companies like SpaceX are racing to make lunar landings routine. It's an international effort, and that's a good thing, because the challenges are massive, and no single country or company can tackle it alone. Imagine a future where NASA, ESA, SpaceX, and other players like Blue Origin are working together, not competing, to establish a permanent human presence on the moon. Collaborative missions could pool resources, share technology, and create a thriving lunar colony faster than anyone could on their own. The moon is more than just the first step in our journey. It's the gateway to everything that comes next. If the moon is our first step, then Mars is the ultimate frontier. Mars has captured our imagination for centuries, and for good reason. It's the most Earth-like planet in our solar system. It has days that are only a little longer than Earth's, it's got polar ice caps, and it even has seasons. But don't let that fool you. Living on Mars is going to be a massive challenge. Still, its potential for colonization makes it the prime target. Unlike the moon, Mars has enough gravity to keep a long-term human presence more comfortable, and its vast landscapes offer space for entire cities, industries, and possibly one day even agriculture. But getting to Mars is the easy part. Living there? That's where things get tricky. For starters, the atmosphere is incredibly thin, about 1% the density of Earth's, and mostly carbon dioxide. So, breathing on Mars isn't an option unless you're inside a habitat or wearing a spacesuit. Then there's the radiation. Without a thick atmosphere or magnetic field like Earth's, Mars is constantly bombarded by cosmic radiation, which is dangerous for humans. Add to that the unpredictable dust storms, which can last for weeks and cover the planet, reducing visibility and potentially crippling solar-powered equipment. It's a hostile environment, no doubt, but humans have never been ones to back down from a challenge. That's why there's so much interest in terraforming Mars, basically transforming the planet to make it more like Earth. Sounds wild, right? But there are actually some ideas on the table. One theory is to thicken the Martian atmosphere by releasing greenhouse gases, which would trap heat and warm the planet over time. Another concept involves creating artificial magnetic fields to protect Mars from radiation, possibly by setting up massive satellites in orbit to generate the magnetic shield. And then there's the idea of greening the planet, introducing genetically engineered plants that could survive in Mars's harsh conditions and slowly convert the CO2 in the atmosphere into oxygen. None of these ideas are close to being ready yet, but they're not entirely out of reach either. In the meantime, though, Mars colonies will have to adapt to the planet as it is. So, what might a Martian city look like? Well, underground habitats are probably our best bet at first. By building cities beneath the surface, colonists could take advantage of the natural insulation to protect against radiation and extreme temperatures. There's also the possibility of dome cities on the surface, giant biodomes with controlled environments, providing a small slice of Earth on an alien world. These colonies would likely be powered by a mix of solar, nuclear, and potentially geothermal energy, with systems in place to recycle water, air, and other vital resources. And how soon could all this happen? Well, if you ask NASA and SpaceX, sooner than you think. NASA's Artemis program is setting the stage for lunar exploration, but their eyes are also on Mars, with plans for human missions sometime in the 2030s. Meanwhile, SpaceX is pushing even harder. Elon Musk's dream of sending humans to Mars could become reality as early as the next decade, with their Starship designed to carry large crews and cargo. Other space agencies and private companies are getting involved too, creating a sort of Mars space race. So, while Mars colonization is still a daunting task, the wheels are already in motion. The first humans to set foot on the red planet are likely already alive today. Once we've established a presence on Mars, where do we go next? Well, beyond Mars lies the asteroid belt, a vast, untapped treasure trove of resources. These aren't just lifeless rocks drifting in space, They're filled with precious metals like platinum, nickel, and even water. In fact, some estimates suggest that the total value of the materials in the asteroid belt could dwarf the economies of entire nations. Water, in particular, is the key here, not just for drinking or creating oxygen, but as a resource for rocket fuel. By splitting water into hydrogen and oxygen, we could create a refueling network in space, allowing us to travel farther without having to bring everything from Earth. Mining the asteroid belt is like the space version of a gold rush, but it's not going to be easy. First, you've got to get to these asteroids, and they're constantly moving. Once there, you need to develop the technology to mine in zero gravity, something that's still in its infancy. But private companies like Planetary Resources have already set their sights on this, envisioning a future where we're extracting valuable elements and sending them back to Earth, or using them to build and sustain colonies deeper in space. It's a critical piece of the puzzle for long-term space colonization because, at some point, we're going to need to rely on off-world resources to fuel our expansion. But if the asteroid belt is where we get our materials, the real excitement lies in the moons of Jupiter and Saturn. Europa, Titan, and Enceladus all have something that Mars doesn't: liquid water. Europa, one of Jupiter's moons, is covered in ice, but underneath that icy shell there's believed to be a vast ocean of liquid water, possibly even teeming with life. Titan, Saturn's largest moon, is a bit more Earth-like, with thick clouds, lakes of methane, and a nitrogen-rich atmosphere. It's incredibly cold, but it's also one of the most intriguing places in the solar system for potential colonization. Then, there's Enceladus, another icy moon of Saturn, known for its plumes of water vapor shooting out from beneath its surface. Yet another sign that liquid water, and maybe even life, could exist there. Colonizing these moons, however, comes with some serious challenges. For starters, they're really far from Earth, hundreds of millions of miles away. That kind of distance makes communication a nightmare, with signals taking anywhere from 30 to 90 minutes to travel back and forth. Energy production is another issue. Solar power becomes less effective the farther you go from the sun, so we'd have to rely on other sources like nuclear power or harnessing the natural geothermal energy from these moons themselves. And then, there's the sheer cold. These moons are incredibly frigid, with temperatures far below anything we've experienced on Earth. The low gravity is another factor. Humans would need to adapt to living in these extreme conditions, which could involve everything from genetic modifications to the use of advanced exoskeletons to maintain muscle and bone strength. It's a completely different environment from anything we've ever dealt with before. But if we've learned anything from space exploration, it's that humans are incredibly resilient and adaptable when we need to be. Life in the outer solar system would be unlike anything we've ever experienced. Isolated, cold, and dark, but also full of potential. Colonizing these moons could open the door to some of the greatest discoveries in human history, especially if we find evidence of life. And who knows? Maybe one day, these moons will become bustling outposts, supporting missions to even more distant destinations like the moons of Uranus and Neptune, or maybe even beyond our solar system altogether. As we look beyond Mars and consider deeper space colonization, one thing becomes clear: we won't be able to take everything we need with us from Earth. That's where space mining and resource utilization come into play. Imagine if, instead of launching costly shipments of supplies from Earth, we could mine the resources we need from asteroids, moons, or even other planets. These materials could drive space economies, allowing us to not only survive but thrive in space. Water from asteroids could be split into hydrogen and oxygen for fuel and life support. Metals could be used for building habitats or spacecraft, and other rare elements could power advanced technologies. Space mining could be the backbone of a self-sustaining space civilization. This concept, using the resources available in space rather than relying on shipments from Earth, is known as in situ resource utilization, or ISRU. It's all about working with what you've got. For instance, on the Moon, we could use lunar regolith, the dusty soil covering the surface, to build habitats, roads, or landing pads using three-dimensional printers. On Mars, the atmosphere is mostly carbon dioxide, which could be converted into oxygen for breathing or rocket fuel. Water ice found on the Moon, Mars, and even asteroids could be used for drinking, agriculture, and fuel production. By tapping into these local resources, we reduce the cost and complexity of space missions and make long-term colonization much more feasible. And it's not just governments like NASA looking into this. Private companies are racing to be the first to tap into space's vast resources. Companies like Planetary Resources and Deep Space Industries are leading the charge in asteroid mining. Their goal? To make space mining commercially viable, extracting valuable metals and elements from asteroids that could fuel not only space missions but also Earth-based industries. Think about it. Why dig deep beneath the Earth's surface when we can mine a single asteroid that contains more platinum than has ever been mined on Earth? These companies are working on developing the technology needed to find, capture, and mine asteroids, and while we're still in the early stages, the potential is staggering. The growth of this private sector is a major shift in the space industry. It's no longer just government agencies exploring space. The commercial sector is pushing the boundaries of what's possible. And as more companies join the race, we could see space mining become a multi-trillion-dollar industry, with entire economies built around the resources of the solar system. This won't just support space colonization, it could revolutionize the way we live and work on Earth as well. The future of space is intertwined with the resources we can harness, and space mining is poised to be the fuel for humanity's next great leap forward. As exciting as space colonization sounds, it brings up some complex questions about who actually owns space and how colonies will be governed. Right now, space is often referred to as the final frontier, but who gets to claim it? There's no clear-cut answer. The Outer Space Treaty, signed in 1967, states that no country can claim ownership of the moon, planets, or other celestial bodies, and that space is the province of all mankind. But this treaty was created long before the idea of mining asteroids or setting up colonies on Mars became realistic. So, as we move closer to actually settling other worlds, we'll need updated legal frameworks to decide how resources are shared and who has jurisdiction over these off-world colonies. Will they be governed by the nations that send them, or will we create some kind of interplanetary governance system? Ownership is just one part of the equation. There are deep ethical questions tied to space colonization as well. For instance, what are the environmental consequences of transforming planets like Mars to suit our needs? If we terraform Mars or mine asteroids, are we destroying potential ecosystems or altering worlds that might one day harbor life? Even though we don't see signs of life on these celestial bodies yet, is it morally right for us to treat other planets the way we've treated Earth? And then there's the question of the rights of future space inhabitants. Colonizing another world would eventually lead to generations of people born and raised in space. What rights do they have? How do we ensure their freedom, well-being, and ability to thrive, even though they never chose to leave Earth in the first place? These ethical issues are closely tied to the politics of space. On one hand, space colonization will require unprecedented international collaboration. No single country or company can do this alone. It will take a global effort to pool resources, technology, and expertise. Agencies like NASA and ESA are already working with private companies like SpaceX to get the ball rolling. But as we start to access valuable resources in space, like minerals from asteroids or water from the moon, there's potential for competition to spiral into conflict. What happens when countries start competing over who gets access to the richest asteroid or the most habitable part of Mars? We could be looking at a new kind of geopolitical tension, where space becomes the next battleground for control over resources. So, while the dream of space colonization is thrilling, we need to think carefully about the ethical and political challenges ahead. Can we learn from the mistakes we've made on Earth and ensure that space doesn't become a free-for-all of exploitation? Will countries work together for the common good, or will space become the next stage for global power struggles? These are big questions we need to answer as we take our first steps toward becoming an interplanetary species. So what does it actually take to build a life beyond Earth? For starters, humans will need to adapt, both biologically and technologically. Life in space is very different from life on Earth, especially when it comes to things like gravity. On the Moon or Mars, gravity is much lower, which means our muscles and bones will weaken over time. This has already been observed in astronauts who spend long periods on the International Space Station. To counter this, we'll likely need to develop new ways of keeping our bodies strong, everything from advanced exercise equipment to gene therapies that help maintain muscle and bone density, clothing or habitats. But it's not just our bodies that will need to adapt. Our societies and cultures will evolve too. Living in space will change everything about how we think of ourselves. What happens when people start to see themselves not as Earthlings, but as Martians or Lunarians? Will new cultures develop, shaped by the unique challenges and experiences of life on another planet? Imagine the kinds of art, music, and traditions that could arise from people who've never known life on Earth. And then, there's the question of how space colonization will affect human identity. If you're born on Mars, do you still feel connected to Earth? Or will we see a shift in how people view nationality and global citizenship? Colonizing space could change our entire sense of who we are and where we belong in the universe. To make these colonies sustainable in the long run, we'll also need to build self-sustaining economies. That means developing systems for agriculture, manufacturing, and trade that don't rely on constant shipments from Earth. Growing food in space is one of the biggest challenges, especially on planets where the soil and atmosphere aren't suited for Earth-based agriculture. Scientists are already working on ways to grow crops in space using hydroponics, vertical farming, and even genetically modified plants that can thrive in Martian soil. Manufacturing in space will also be key, especially using 3D printing and local resources to build everything from tools to entire habitats. And then there's trade. Colonies on Mars, the Moon, or asteroids will need to trade with each other, exchanging resources like water, metals, and food to build a thriving interplanetary economy. In the end, building a sustainable life beyond Earth isn't just about surviving. It's about creating entirely new societies, economies, and cultures. It's the next great chapter in human history, and while the challenges are enormous, so are the possibilities. This journey will redefine what it means to be human, stretching the boundaries of our potential and reshaping our future among the stars. So, once we've established colonies throughout our solar system, the universe is vast, and while Earth may be our cradle, it's clear that we won't stay here forever. The future of humanity lies in the stars and oversight. When we think about constructing habitats on the Moon or Mars, AI can be used to automate the building process. Robots, guided by sophisticated algorithms, could assemble habitats from locally sourced materials, ensuring that our bases are operational long before human settlers arrive. Explorers. The relationship between humans and machines in space colonization is destined to be one of collaboration. This human-machine partnership can lead to incredible efficiencies and innovations, allowing us to tackle challenges that would be insurmountable alone. For instance, humans possess creativity, intuition, and emotional intelligence, traits that are essential for problem-solving in complex situations. AI, on the other hand, excels at processing vast amounts of data and performing repetitive tasks with precision. Together, they can complement each other perfectly. In a colony setting, AI could manage life support systems, monitor environmental conditions, and even assist in agricultural practices, while humans focus on decision-making, community building, and scientific exploration. Imagine a scenario where AI algorithms are not only managing day-to-day operations but also providing insights for long-term planning. If unexpected issues arise, like a sudden dust storm on Mars, the AI could analyze the situation, recommend immediate actions, and even assist in rerouting tasks or resources. This collaborative dynamic could be crucial for maintaining safety and efficiency in a setting where human life hangs in the balance. Moreover, space colonization could dramatically reshape human civilization itself. As we establish colonies on the Moon, Mars, and beyond, we'll see the emergence of new cultures, economies, and perhaps even new forms of governance. Each colony will develop its own identity, influenced by its unique environment and the challenges it faces. Think about the cultural exchanges that could arise. Imagine the blend of Earth traditions with Martian adaptations, leading to entirely new art forms, languages, and social structures. Economically, these colonies could thrive on resource utilization, leading to innovations in trade and industry that are unimaginable today. And governance? With the vast distances and different challenges, we may need new models for leadership and cooperation that prioritize collaboration over competition, fostering a sense of unity among different colonies in the solar system. Ultimately, the vision for the next millennium is not just about survival in space, it's about flourishing as a diverse, interconnected species that embraces its role in the universe. Our journey beyond Earth could lead us to discover not only new worlds, but also new ways of thinking, living, and being.